guys, thanks for clicking on this video and actually watching it. Please watch to the end so you can actually understand what's going on. I do want to say that I can see like the average duration of watch time, like the average watch time for my videos, and I do want to say that it's about 4 minutes, and my videos are not 4 minutes long, and I don't appreciate it as much. But to those of you who are watching, I really do appreciate it. It means a lot to me because I'm putting a lot of work into these things, and I just want to help you guys learn. So I'm going to go ahead and mention the grade. I'm sure you've looked on live grades recently. If you haven't, you should. So the grade in the fourth 9 weeks on live grades, I think I've finally got it completely figured out how I want to do it, is what you're going to get for fourth 9 weeks. I put in a grade for what you got last 9 weeks, and which messed up your last 9 weeks grade on live grades. Just ignore it. It's still going to be exactly what you got on your report card this last time. But now what you see on your fourth 9 weeks is actually what you're going to get on your fourth 9 weeks. So if you don't turn things in, it's not going to bring your grade down, but if you turn things in, it will bring your grade up, because I know that there are a lot of things going on, and I think that this might help some of you out. So the first couple pages of this is just going to be review, and I'm going to go over some problems so that you kind of have a little more explanation of how these kinds of problems are going to go. So for the first ones, it's just asking you to do a trig ratio, write it as a fraction. So it's going to tell you one of the sine, cosine, or tangent, and it's going to tell you what angle it wants you to look at. So the first step is to mark the angle you're looking at. Okay, so if it tells you you're looking at angle C, so sine of C, and you have a triangle like this, and it's labeled ABC, you're looking at angle C, mark angle C so that you can actually see which angle you're looking at. After that, you can go ahead and write the ratio. Okay, so you're going to use so, ka, toa. So what I want here is sine of what angle, whatever angle you're looking at. So here was C, sine of C, opposite. That's what the O stands for. And it's divided by H is hypotenuse. If it asks you for cosine, you're going to write cosine of whatever angle, we're going to say C, is equal to adjacent. That's what the A stands for. So the first one divided by the second one. The second one is hypotenuse. That's what H stands for. If it asks you for tangent of some angle, say tangent of C, you're going to do opposite. So that's what O stands for. Divided by the second one is adjacent. Okay, so write that out. After that, put in the numbers. Okay, so if you know that the opposite side is 5 and the adjacent side is 3, okay, and you're looking for tangent, tangent of whatever is going to be opposite over adjacent, like we've got here. Okay, opposite side is 5, adjacent side is 3. Literally just write it as a fraction. So looking at the actual problems now, number 1 tells us tangent of C. So we're looking at angle C here, so we'll mark angle C. We're looking at tangent, so I'm going to go ahead and write so, ka, toa up here. Okay, so tangent of angle C is going to be opposite over adjacent. So the first one is opposite. A means adjacent. And then from there, we're going to label. Ooh, that's what you need to do. Forgot to even mention it. So in between these ones, when you write the ratio, or after you mark the angle, really, we'll say that's 2, this is 3, and this is 4. Label the sides. Okay, so you're going to need opposite, hypotenuse, and all these things. You want the opposite, the hypotenuse, and the adjacent side labeled on your triangle. So in this case, directly across from the right angle, which is in all cases, is the hypotenuse. Directly across from the angle we're looking at is the opposite side, and then the leftover side is the adjacent side. So opposite here is 30, divided by the adjacent side is 40. And then if you want, you can simplify that to 3 over 4. Okay, that's all you're doing. So if we look at the next one, we're looking at angle Z here. Okay, so we'll mark the angle. We'll go ahead and label the sides. Directly across from the right angle is the hypotenuse. Across from the angle we're looking at is the opposite angle. And then the leftover angle is the adjacent, or the leftover side is the adjacent side. So in this case, we're looking at cosine. So we have cosine of z is going to be equal to adjacent and hypotenuse. So adjacent divided by hypotenuse. Okay, the adjacent side is 20, and the hypotenuse side is 29. Since that cannot be simplified, we'll just leave it at that. Then for the next one, we're looking at angle C, because it's sine of C. Thank goodness, because I don't have the other side even on here. I clipped it off accidentally. So we're looking at sine of C. Label the sides. Directly across the right angle is going to be the hypotenuse. Directly across the angle we're looking at is the opposite side. And then the other one's going to be the adjacent side. And it's called that because it's actually adjacent or touching the angle we're looking to. Okay, so we're looking at sine of C. Okay, if you look up here, sine is opposite over hypotenuse. That's what those stands for. Okay, the opposite side here is 21. Hypotenuse is 29. Literally just write them as a fraction. And since it can't be simplified, that's all you gotta do. So in these next types of problems, we're actually looking for either a side or an angle that's missing. So first step, again, is to mark the angle you're looking at. Always start by marking the angle you're looking at. After that, we're going to label the sides. Okay? Now that we have the sides labeled, we're going to decide which trig function fits. So like if you have only the opposite side and the adjacent side, opposite and adjacent is tangent. If you have the hypotenuse and the opposite side, hypotenuse and opposite is going to be sine. Just see which one of those fits. From there, you can substitute the numbers in. Substitute the numbers in and solve. The main thing to remember, okay, really important, is that if you have like sine of 15 degrees or cosine of 90 degrees, those are just numbers. Okay, they're just numbers. You can add them, you can subtract them, you can do anything that you can do with like 3 or 4. If you can multiply by 3 or 4, you can multiply by sine of 15. It's just going to be a number. If you type sine of 15 in your calculator, you're just going to get some number between 0 and 1. So if we look at number 11, we'll start out by marking the angle we've got. You can see this 15-degree angle here is the one we're looking at. Then we can label the sides. Across from the right angle is the hypotenuse. Across from the side we're looking at is opposite. And then the extra side, or the side directly touching our angle, that is not the hypotenuse, is going to be the adjacent side. Okay? So we have the adjacent and the hypotenuse, or the adjacent and opposite. We don't have the hypotenuse. So TOA. Okay? So the only one without hypotenuse is going to be tangent. So tangent of x is going to be opposite divided by adjacent. Okay, so tangent of this angle x, this one we've got 15 degrees specifically. Okay, it's going to be equal to opposite x, so the one we're missing, divided by adjacent is 11. We're literally just going to solve for x. Since it's being divided by 11, the inverse of division is multiplication, so we'll multiply by 11 on both sides. Cancel this side out, so it'll give us x is equal to tangent, or 11 times the tangent of 15. Type that in your calculator, okay? And you're going to get about 2.9. So this little side over here, from there to there, it's about 2.9. So if we look at the next one, again, mark the angle first, and then label the sides. Across from the right angle is the hypotenuse. Across from the angle we're looking at is the opposite, and then the other one's going to be the adjacent side. This one we're not using adjacent. The ones that have adjacent in it are those two, so we're going to have to be looking at this one. So we're looking at sine in this case. So sine of whatever angle we've got is going to be equal to opposite, so O looks for, or stands for, opposite divided by hypotenuse. Okay, so So we have sine of 42 degrees here. Opposite is x, and the hypotenuse on this triangle is 18. So again, we're going to solve for x, so we'll multiply by 18. Those will cancel, just giving us that x is equal to this whole left side here. 18 times the sine of 42 degrees. Type it in your calculator. You don't have to type the degree symbol, but type 18 times sine of 42. That's going to give you about 12. So this side from here to here is 12 long. In these ones, we're actually looking for the angles, so we're still going to use SOHCAHTOA. Okay? We're marking this angle because that's the one we're looking for clearly. And then we're going to label the sides. So across from the right angle is the hypotenuse. Across from the one we're looking at is the opposite. Other one's the adjacent. Okay? We do not have the adjacent again. So the only one without adjacent is going to be sine. So we have sine of whatever we've got here. We'll say x is equal to opposite over hypotenuse. Okay, so that just came from here again, O over h, opposite over hypotenuse. So again, we don't know what our angle is, so we'll just label it x. Opposite is 25, divided by hypotenuse is 52. Okay, and now, in order to undo sine, we need an inverse trig function. So an inverse is just something that undoes another function. So like if we have 3x equals 12, multiplication, we need an inverse for 3 times x. We're going to divide by 3 instead, because division is the inverse of multiplication and it cancels it out. So in this case, we're going to take the inverse sign of both sides. So I'm going to write it above it, inverse sign of that side too. When you take the inverse sign, it's going to cancel those two out, just leave us with x. But on this side, we have sine inverse of whatever we already had. So 25 divided by 52. You can type that in your calculator and just get a decimal. Okay? It's going to give you a decimal, but in order to get the sine inverse, you do the second button or the shift button on your calculator, and then you just type the sine button like you normally would. If you type that in, you're going to get about 29 degrees. So this angle here is going to be about 29 degrees. On this one, we're looking at this angle here clearly, and we'll label it x again, because we don't know what it is. Directly across from the right angle is the hypotenuse. Directly across from the angle we're looking at is the opposite side. And then the other angle, or the other side, is the adjacent side. So in this one we have hypotenuse and opposite, and no adjacent, again, accidentally. So hypotenuse and opposite is going to, again, be sine. So we have sine of x is going to be opposite over hypotenuse. Okay, so again we have sine of x because we don't know what the angle is. Opposite is 27, hypotenuse is 43. Since we want rid of sine, we're going to have to take the inverse sine of both sides. Put my parentheses around that a little better. Okay. Cancel those two out to give us x. This side has the sine inverse, and then the fraction we already had. Okay. Type that in your calculator. Again, second or the shift button, and then the sine button, and then just type in the fraction as 27 divided by 43. It's going to give you about 39 degrees for that. So that angle is going to be about 39 degrees. So again, mark which angle you're looking at, label the sides, figure out which of these trig functions fits the sides that you've got labeled, or that are marked actually with numbers, so labeled with numbers, and then try and solve for the x that you need, the missing side or angle. Okay, so next we're going to get into the actually new stuff, and we're going to be looking at, I guess you could call them word problems. They're more applications of trig, so ways that are a little more realistic ways that we actually use them. So, the first step to any of these things, any of these problems, is to draw a picture. Okay? You need to draw a picture and label everything. So any side length or angle they give you, whether you think you're going to know it or need it or not, you need to write it down. And after that, you're just going to solve like before. Okay? Make sure you look at keywords. 2 keywords we haven't really looked at before that are going to come up here are angle of elevation. So that's if you have something at the bottom and it's the angle going upward, whichever way you're looking at it. Literally the angle just going upward from the bottom. And then we also have the angle of depression. So you can tell which one is clearly positive or going upward and which one is negative and going downward. So that's like if you have the ground or something up high and you go downward from it, that's going to be the angle between those. Or like just the angle going downward, so starting at the top and going down. So just check for keywords, label everything you got, draw a picture, solve just like we just did. So I think I've moved myself so I can actually see up here now. So I've got Toa. I'm going to go and write that up there so I don't forget it. But let's read the problem out and draw a picture. So you're painting a house. So I'm going to go and draw the house. Okay. This is my beautiful house. This is my beautiful house. Hope you enjoy it. And you're leaning a ladder against it to get the top of the wall. Okay, so there's our ladder. The angle between the ladder and the ground, so this right here, this angle between the ladder and the ground is 45 degrees. We know this one's going to be 90 degrees. Otherwise, you might want to call your contractor because your house should be at a 90-degree angle with the ground. Otherwise, it's going to fall over. So the bottom of the ladder is 3 feet from the wall. So from here to here is 3 feet. How far up the wall does the ladder hit? So how far up is from here to here? So you read the problem and write all the numbers down. Draw the picture. So I'm going to go ahead and draw this triangle a little bit over here and put the numbers in so we don't have my beautiful drawing in the way. Okay, I'll label X for the one we're not sure about. And now we're just going to go ahead and go through the movements that we went through earlier. Label the angles, or choose the angle you're looking at, label it, mark it, whatever. Label the sides, so across the right angle is the hypotenuse. Across the angle we're looking for is the opposite side, and then the other one's the adjacent side. Okay, so we have opposite and adjacent. We don't have a hypotenuse. That's going to be tangent here because it has opposite and adjacent. So we have a tangent of x. We have 45 degrees here. We'll go and do it that way. We don't have to write it all out. Okay, tangent is going to be opposite over the adjacent. So this tangent of 45, we put in the numbers there. Opposite is x. Adjacent is 3. And then from there, we're just solving for x like we usually would. Since they're dividing by 3, we'll multiply by 3. Gives us that x is going to be whatever's on the left here. So 3 times the tangent of 45 degrees. Type that in your calculator. You're going to get about 2.1 feet. Okay? And I picked the numbers randomly for these, so I'm sorry that you are only having like a 3-foot house in this case, but the length from the bottom of the ground to the top of the ladder is going to be about 2.1 feet in this case. So just make sure you draw your picture and label everything while you do so you get a triangle that you can work with. So now we will look at number 24, draw a picture. So we have a tree that's 9.5 meters tall. Okay, I'm going to draw this tree. It's a Christmas tree, as it is the only kind of tree I can draw. It's a very bad Christmas tree, but it's there. Okay, so there's a tree, and it's 9.5 meters tall. Okay, and it's going to be 90 degrees from the ground because trees grow straight upward. Okay, so we have, I labeled that at the wrong spot. This from the bottom to the top is 9.5 meters. Okay, so the height. It casts a shadow, so I'm going to draw its shadow. That's kind of what it looks like that, kind of. Okay, and that's going to be 3.8 meters long. And if we connect this, it's asking us what is the angle of elevation to the sun. So shadows are created by the sun, so you can go on up and see the sun up here. I'm an artist. I can't help it, guys. Sorry for my beautiful artwork. You're welcome. I mean, So we're looking for the angle of elevation. So you can see that angle of elevation starts at the ground and goes up. So we're going to be looking at this angle. I'm going to label it X. So if you can see with this beautiful drawing, we have a triangle here. I'm going to go and draw it over here a little better so you can see it. So we have the right angle here. We have the 9.5 meters on this side, 3.8 this way. Okay, and then we have this angle we're looking for, X. Okay, so this makes it a little simpler to see. It's always better. But we needed the picture to see where everything went. So we label this angle that we're looking at, and then label the sides. So across the right angle is the hypotenuse. Across from the angle we're looking at is the opposite side. Then the other one's going to be the adjacent side. Okay, so again this time we don't have the hypotenuse. So if we're looking at SOHCAHTOA, this one has a hypotenuse, this one has a hypotenuse. We're looking at tangent. So tangent of this X, the angle we're looking for, is again going to be opposite over adjacent. Okay, so that's what the O and the A stands for. So tangent of X is equal to opposite is that 9.5 divided by the adjacent is the 3.8. Then we got to solve for X. Since we have tangent of X, we have to get rid of tangent. So we have to do tangent inverse of both sides. Sorry, so we applied tangent inverse to both sides. Okay, so these ones are going to cancel out. Giving us just X. Then we're still going to have tangent inverse of this fraction, which you can just type in the calculator. If you need to type tangent inverse in or inverse tangent, arc tangent, there's plenty of words to use for it. You're just going to click either the shift button or the second button, whichever button your calculator has, and then the tangent button. And when you do, you're going to get about 68 degrees. And if you don't, you need to check your mode on your calculator, go to your settings or something and make sure you're in degrees and not radians. So again, draw us a picture, label all the sides and all the angles it gives you. If you need to, take that picture and draw an actual triangle out of it, and then just solve for the missing side or angle like you would before. So for this problem, we have an airplane flying, so I'll draw my airplane. So we'll have that kind of a thing, I think. And then they have a windshield and all the little things on it. Okay? So those are windows, by the way. It's flying. It is flying at 40,000 feet up, so 40,000 feet right angle with the ground because it's straight up. Okay, I'll put my unit on there. Angle of depression to the airport runway, so you have to draw the line up there to where it is. Angle of depression to the runway, so I'll draw my little thing. And this is going to be the runway where it took off at. And when it turns around, you know. Okay, angle of depression, so from the top down, so it's going to be this angle, not this one, because it's actually from the top downward, is 12 degrees. Okay, how far is the airplane to the runway? So how far from the runway is the airplane? So this part, that's what we're looking for. So we need this angle, or one of the angles in the actual triangle we have. So this is going to be a 90-degree angle. 90 minus 12 is going to be 78 degrees. Okay, so now we can look at the triangle. Again, I'm going to draw it separately because this is going to make this a little easier. So we have a 78-degree angle, a right angle here, 40,000, a really big number, and then we're looking for this one. So we can now label the sides. The hypotenuse is across from the right side, the right angle, sorry. The opposite side is literally opposite the angle we're looking at. And then the other one is going to be the adjacent side. So, SOHCAHTOA is what we're using again. So we do not have the hypotenuse, and again, the only one without hypotenuse is tangent. So we have tangent of our angle, our angle 78. What is going on? Okay, is going to be opposite divided by the adjacent. Okay, so this tangent of 78 degrees, opposite is x, so the one we're missing, then adjacent is 40,000. Okay, so to get rid of that 40,000, we'll multiply both sides. What is a 4? I don't know why it changed to a 9, but that will give us x is equal to whatever you get when you take 40,000 and multiply it by the tangent of 78. So if you type that in your calculator, I'm just going to round it off to the nearest whole number because it is pretty big. So it's about 188,185 feet. So they've went pretty far from here to here. Okay, so which is good because otherwise they'd be going way too fast. So just make sure you pay attention to the wording in the problem. So angle of depression is from the very top down, so you might have to draw another line for it if you need to. Angle of elevation will always be from the bottom up, so you'll be opening upward or downward from a horizontal line on both of those. Okay, draw the picture, make sure you label everything you got, solve from there. Okay, and lastly, let's do number 28. So a searchlight shines on a flying saucer, so we can go ahead and draw a flying saucer. Okay, that's what it's going to look like, I think. I don't know. Ooh, we got some lights everywhere, you know, looking real fancy. Something for the little aliens to look out of. Like a windshield kind of thing. There we go. Yeah, I feel like that's pretty good. Okay, and the searchlight shines on a flying saucer 100 feet directly above it. So we can draw the searchlight. Somebody's looking for them clearly. And just 100 feet directly above it. Okay, this is going to be 100 feet. Okay. Another searchlight down the road shines at it. So there's going to be another one down here. Okay. A lot of people are looking for aliens now. This is in light of the recent Pentagon confirming the videos thing about the unidentified flying objects, so UFOs, but creating a 30-degree angle between the two lights where they both hit the flying saucer. So we have a 30-degree angle here. How far apart are the searchlights? So we're looking for this one. Again, this is a right angle since it is directly straight upward. We're looking for this side. So if we move this onto a triangle that isn't bogged down by my amazingly, beautifully, perfect artistic drawing, we can put the X here. We know this is a right angle. This is 30 degrees. And this is 100 feet up. Okay, so with that we can label the sides. So across from the right angle is the hypotenuse. Across from the angle we're looking at is the opposite side, and then the other one's the adjacent side. So again, on this example, we do not have a hypotenuse. So if we're looking at SOHCAHTOA, you can see we're still looking at tangent. And I do want to say that it's not always going to be tangent on word problems. I just so happened to literally pick every tangent problem that there is on the paper. Basically, I don't know if there's any other ones really, but I picked every one of them. Every one I picked is tangent. So it could also be sine. It's not always going to be tangent. But tangent of this 30-degree angle, okay, it's going to be opposite over adjacent still. This is my cat Tofu. She decided to come and join us, so I thought you guys would like to see her. But continuing on, tangent of 30 degrees is opposite over adjacent. So if I take this tangent of 30 degrees, the opposite side is x, so the one we're missing, and then the adjacent side is 100. So in order to solve for x, we need to multiply by 100. Okay, so that gives us that x is equal to 100 times tangent of 30 degrees, which we can just type into a calculator, and that's going to give us 57.7 feet. So these two searchlights, very lucky searchlights, are 57.7, almost 58 feet apart. And that's basically it. So thank you guys for watching. I will see you guys later, and I hope you guys have an amazing week. Let me know if you have any problems, and I'll help you the best I can. Bye, guys!